Hey guys, it's Miss Sebastian. So we're going to look at 6.08, Interpreting Linear Models. So this first type of question you may see on your assessment is the function described by the points in this table linear or nonlinear? So the first thing that I want to look at is check and make sure that the rate of change is constant, or the slope is constant. And what that means is I'm going to find the difference between my points and make sure it's the same between every one of these. So I've got 5 and 0. So 0 minus 5, this went down -5, and my x's went up 1. -2 minus -3 gives me +1. I can go all the way down here. These are all changing by the same number. These are all a difference of 1. But let's check here. 0 to -3. Well, that went down. -3. Then it went down just 1. Up 1. Up 3. And up 5. Now if I look at these numbers, it's not the same number every single time. For it to be linear, it needs to be constant. Constant means it stays the same. So this is non-linear. It is not a constant rate of change. Okay, let's look down here at this one. Which table contains a set of non-linear ordered pairs? So we've got a table here, here, and here. So I'm looking for non-linear. That means they have a rate of change that is not constant. Now, if I look at my x's, 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3, and 0, 1, 2, 3. They're all the same, so I don't really have to find the difference between each of these on this problem, but others I would. So let's go ahead and find the rate of change. So the difference between 7 and 4 is 3. Between 7 and 10 is 3. Between 10 and 13 is 3. Notice that all of these have the same rate of change, so this one is linear. Now let's look at this one. It's got a difference between 2 and 1 of 1, between 2 and 5 of 3, and between 5 and 10 of 5. Notice these are different numbers, so this one is nonlinear and probably the answer we're looking for, but it may ask you to check and select all answers. So let's go ahead and do the next ones. The difference between 2 and 1 is 1. Between 2 and 3 is 1. And 3 and 4 is 1. Notice a constant rate of change here, so that does make this one linear. And here we're going to find the difference between the y's. 5 and 7 is -2. 5 and 3 is -2. 3 and 1 is -2. Okay, I'm subtracting the bottom from the top here. So I did 5 minus 7, 3 minus 5, 1 minus 3. You could have also gone the other way, and that is fine. Just notice they are all constant here. It's all the same number, so those are linear. So we would say that this one is our answer. Now, an easy way to tell the difference when you're given a formula or an equation for a function. It's asking if it's linear or nonlinear. Easy way. For nonlinear, any exponents other than 1 or x in the denominator. And that's like 3 over x. Okay? Or x to some power. If you look right here, this x is being raised to the 3rd power, so right off the bat, I could tell that this one is nonlinear. If it has any exponents or your equation has x in the denominator, it is nonlinear. Okay, let's look at this one. Okay, we've got another table, and it says a function is represented by the values in the table. Okay, and it wants you to choose is or is not linear. So we've talked about how to find that out. Okay, we're going to go up here, and we're going to make sure that our difference is the same in all of these. -3 to -2, it's going up 1, going up 1, going up 1, and going up 1, so that is constant. But let's check our y's because that's what really makes the difference in these. -4 minus 7, so that's going down -11. 1 minus -4, well that's, oh, +5 there. Now we're going to go down 1, 3, so it's going down -3, and then we're going up 7. Well, as you can tell, these numbers are not the same, so I would choose is not linear. I hope this helps with 6.08, Interpreting Linear Models.